What's up, everyone? Back with another tutorial today in R. We're going to be manually creating and plotting event data. Um, and these are both going to be created using data that we're going to make ourselves through event trackers, such as the shot plotter from Anne, and then the soccer event logger from Ben Torvany that I will link both of their Twitter accounts below. Um, Fantastic public tools that when you take these and combine them with the code I'll use today, it's an instant analytical department, I guess you could say. You're going to be able to create and keep tabs on a database of shots. Some broken down by players, positions on the field, on the court. So I highly recommend this tutorial for high school coaches in basketball or soccer or any age level, pretty much, especially all the way into college, where this can upgrade the analysis on any side of the game, where you'll be able to create shot charts pretty much not automated, but once you create the data and have the code, it's takes less than a minute to create and save. So I use it personally for a lot of my stuff, and I highly recommend it. So let's dive into it. So we'll do the basketball one first. If I can get out of this. So we will go. I have the link in the code. So this is the shot plotter website that Anne created, or tool. Very simple to use. The way I use it, so this is the court that you are going to be clicking on. So once you click on this, it'll create a located shot. So I'll show you what I do. I usually type in the player's number, and then we have a make or a miss. I don't use blocks personally, but what you do is say number 10 makes a 3-pointer from the left side right here. So it populates a shot attempt at the location you click on, and now in the data frame or data set, you can see here quarter one, home team, player 10, outcome, and then the X and Y location. I don't really pay attention to these, don't use it. You can add more variables to it, but I tend to stay away from that. I just want who took the shot and where. So I'll start populating just some random shots. And my biggest advice is it's not going to be it's not like NBA's events or tracking data where it's pretty much down to the specific spot on the court. There's going to be some human error. So I highly suggest maybe doing this while watching film instead of trying to do it live at a practice or something like that, because then you can start guessing and it doesn't come out as accurate as it should be. So just be wary of that. I'm just going to start populating some random shots. So as you can see how to do it, it's really easy. The interface is fantastic. So this is just some fake proxy data that's just made so we can see what it looks like after. So I'll call this, I think I called it basketball. This is how you download the data, sorry. So we have 26 shots in total. Basketball, I think I call it shots. And then download. So it'll instantly create an Excel file. I'm running this on Mac, so it might be a little bit different on others. So this is what the data looks like. From here, file, save as. You're going to want to save this as a CSV in the location of where your code will be stored. So mine is stored in this little right here, event data tutorial. I'm going to save it as a CSV, basketball shots. Perfect. So we have our data. You can go back and rewind that if I went too fast. Just don't want to spend too much time on this part. So here we go over to the code. So these are the packages you'll need. Tidyverse for data, ggplot plotting, SportyR, which is one of the biggest parts of this tutorial. Fantastic package from my guy Ross. I'll tag him below, also his Twitter page. He created this so you can plot sports courts or fields from football, soccer, basketball, baseball, I believe. CalPlot, which I will get to later. This allows us to take any plot and then put it on top of another background so we can ensure that the whole background is the same color. Dev tools to download the SB pitch library. So we'll run this, get those loaded up. All right, so first we'll go to the basketball data. So we want to read our CSV file in. I call it shots. Okay. Shots.csv. Read that into data frame that I'll call basketball shots. And then here we get to creating the basketball court. This is what's so great about Sporty R is you can pretty much change the color of any part of the court. So Geon basketball is the function for the basketball court. We're going to be creating an NCAA court. And so this is, we'll send this back into the object court. So if we run this whole thing, and then we just type in court, should plot. There we go. So it's just a fantastic package, and it plots very clean and totally customizable. So I'll change one just to show real quick how it can be switched. So let's do, so we'll change this paint color from change the gold so it stands out. There you go. So you guys can play around with that, kind of whatever you want to see, change it to. You know, it could be your team colors. It's probably what I suggest. Looks good in reports. So I'll get rid of that change. And from there, it's very simple. So we have our court function or object. Now we're off to plotting. So first we want to call the court, and then we're going to overlay the points on there. So Geon point function is the ggplot function for scatter plot. So basically just putting a scatter plot on top of the court. So we're using the basketball shots data frame that we created. And then here's the mapping. So the x-axis is equal to the x locations, y is y locations, and then we're going to label it by player number. So let's look at this is the data frame. Sorry. So we have the player, the outcome, make or miss, and then the x and y locations. So and then the size of the point. So we'll go there. This is what it looks like initially. Change it. There we go. So that's what we have so far. The make and the miss, I'll change these colors, but these revert to the base categorical for two variables. It's like a pink and a turquoise and blue green. It's weird, but this scale color manual is what will change that. So this we tell it to react to the color, and then the values for each one. So the make will be green, and then miss red, and then we'll label a make and a miss, made, miss. So that should change it. There we go. And then Geon text, that reverts back to the label. Label equals player. So this is just a color, size, font. So this will create a label for each one and place the player's number inside the shot point, which is very useful as you can easily locate where a player is shot from. And another thing of why it's so great you can label a player's number is you can keep this data saved, and then as the season rolls on or what you want to look historical data, you can just filter for a specific player, and then maybe create a shot chart just for that player. And these are all just a bunch of themes, theme elements that I use to create mine. So I won't go through that a ton. I believe I did in past tutorials, but I'll leave this there for you guys. You can obviously change all that, but that's just a good like skeleton for you guys to work off of. And then we'll add our labs, our labels, title equals, I put practice shot chart from just to today. So we'll throw all that into, we'll pipe or not pipe, I'm not going to say the correct word, but we'll send it back into an object called P1 for plot one. And then I'll show you why we do this. So how Sporty-All works is it doesn't fully respond to the plot in the panel background. So it leaves this white margin. So the way to get rid of that is send it back into P1, and then CalPlot, the package that I talked about earlier, has a function called ggdraw. So it will take this plot one, P1, and now that is a static image on top of this white background will now respond to anything that we want. So now we want plot background, panel background to equal gray 15, which is this dark gray. And there you go. So now you can change the color of the background and the title pops now more. So that wraps up the basketball one. Very simple. So from here, all you gotta do is create the data, save it in Excel to the same folder in wherever you keep it on your computer as the code, then read the data in, read the court function, and then plot it. And then here we'll save it. These are the dimensions I use. And there you go. So now we'll move on to the soccer example. We use, this is the Torvany event tracker. It's a bit different. We can't label it by player, but it'll still work out. So here we go. All you do is just click away. So these will represent misses. So just be mindful of that. And then the way to add a variable or categorical variable to it is by holding in the number 1 on your key. And while doing that, you can click and it will add a modification 1 column, which we will use to represent a goal or no goal. So there we go. That should be enough. Download. This will save as Excel file like the basketball one did. So there we go. Yep. So we have our XY locations, and then like I said, modification 1. See how it changes to true once we held in 1. We'll ignore these two, but what we will do in the plotting is for everything under this column that's true, it will be a different color, which will stand for goal. False will be no goal. But I'll show that later. So CSV, so I call this soccer data.csv. Go to, and then that folder, and then save it. Replace it. That was my old. So then we'll go, here we go, soccer. So we read in our data. Here we go. Mod 1, modification 1. We got our true standing for goals, false, no goals, and then our XY. So to create a pitch in R, I use the SB pitch, so StatsBomb pitch package. I do a little renaming. I rename that column mod 1 into outcome, just so it's easier to differentiate between these two. Outcome of the shot. So the what was it? The StatsBomb pitch. The X runs from 0 to 120, the X-axis, and then Y is 0 to 80. And the Torvany tracker plots from 0 to 100 and 0 to 100 on both axes. So what this little piece of this mutation kind of normalizes it. Sorry, can't think of the word, but basically it multiplies the X-axis by 1.2 to make it, it scales it from 0 to 120, and then the Y-axis 0 to 80. So this will make sure that it plots correctly on our pitch or field. So I just make that a new data frame. There we go. It's perfect. Now we're going to plotting. So pretty much set up the same, just a little bit different. So our create pitch function creates the pitch, and you can customize it a bit with grass color. I make it all gray. That's what I usually go with. So there we go. Okay. And then very similar to what we did earlier, G on point for the scatter points, X equals the X location, Y equals the Y location, color equals outcome. I made the points a little bit smaller. There we go. Then we need to add the scale color manual like we did earlier. So green for a goal, light gray for no goal. And then the breaks equals tells the code to look for which one specifically. So it will look for true, and it will label it goal, and it will color it green, look for false, so no goal, label it no goal, and then fill in gray. So what I'll do is I'll make this first. So this, you want to go into that column. So we have color equals outcome. So true and false in this column. So that's where you put true, false in there. So if you had a third categorical variable, you would add another one here, which we don't, but just if you're doing it differently for anything else, you would add one here, add another color here, and then add another label. But I'll run this just to kind of get a visual look at it. There we go. So now it's goal, no goal. We'll clean this up with the theme, but now it's colored correctly. This just makes sure that the X and Y axis cut off at the correct scale. And then, like I said earlier, these are theme elements. You can play around with these. Ton of great tutorials out there. This isn't anything too crazy, but just a plot background, title, subtitle, caption, where the legend, this part is located. So we do 0.1 and 0.13. So this is the X location, Y location. So it'll be about 10% of the X and then 10% of the Y, 13%. So I'll run that. See what it does. There we go. That's where they see, like I said, 10% adds to the bottom left corner. And then we're going to add our title, subtitle, caption. And then this is a little thing I added. So in annotate, you can add just text to a specific position on the plot. So I labeled it home team. This will go on the left side. So what you want to do, what I thought we'd do is these are the home side plots. Shots. This is all the away side. So when I run that, we'll just add some text there just to differentiate, to make sure that the visual doesn't get confused. So that's the final product. There's no white margin in this one, but I still do the same thing just to make sure. I send it into the P1, GG draw P1, and then plus the themes just to ensure that. So we can run all of that. There you go. So I'll save that. And that concludes the coding part. I'll take a look at the final two. Just so you can get a look at side by side. There you go. You know what? Let's just go to the ball. There we go. So this wraps up the tutorial. Hopefully it was pretty good, broken down well. Obviously, like I said all the time, my DMs are open. Would love to talk to anyone about this, and would love to see if you guys create this. This is, in my opinion, can be very useful for coaches for both sports at any age level. Keep track of the shots also visually, but also if you do this tracking. What I do personally is when I save my files, I save them by date. So when I call it basketball data or soccer data, I usually just put, so for today, I would do 12/28, December 28th. I think I'll be releasing this in a week, so this might be a little outdated, but I save the file by date. That way I can go back historically and see each one. And then if you want to take it by another step, you can bind the data. So you have historical multiple days in one data set. Then you can do some filtering by there, which if you guys would like, I can go through that one time and kind of show how I do that. But yeah, I really enjoyed this one, and it's always cool to kind of create your own event data. It's pretty advanced, I would say, and it will immediately upgrade the analytics department that usually doesn't exist for high school or college teams or even age groups below that. But with these awesome tools and hopefully this code, you can create your own analytical insights for your team. So this wraps it up. Thank you guys again for tuning in for another one, and I'll see you guys next time.